Let me invite on the floor Dieter Schmastig from Graz University. Thanks to be here. Dieter ci introdurrà al tema delle realtà aumentate, di cui è probabilmente uno dei più grandi protagonisti sulla scena internazionale. I suoi lavori sono riconosciuti in tutto il mondo per avere soprattutto permesso a questa tecnologia di avanzare a livelli precedentemente mai visti. Il titolo della sua presentazione oggi sarà Augmented Reality in CultAR and Trend for Future Exploration. So vedremo anche quello che il futuro ci riserverà e credo che questa presentazione sarà molto eccitante. Thank you, Dieter, to be here with us, and good job.
Hello, thank you, Luciano, for the introduction. I would like to talk about the augmented reality part of the CultAR project, and I thought I'd make this short and sweet, not show you lots of technical details, but more the general directions, and also talk about some future trends maybe that go beyond what we have done in CultAR. But let me start with giving you a little bit of an intuition about augmented reality in general. So I think this is a strong trend that we are observing today. So you've probably come across it. Here you see some scenes from the experience that we've done in Padua. And obviously it's a mobile application that runs on your smartphone or tablet, in the case of CultAR, that overlays the real world with computer graphics. And we have been using tablets because they are the most widespread devices right now, but you have probably heard about Google Glass or Microsoft HoloLens. So head-worn displays are also up and coming alongside with all these wearable devices, and this is a really strong trend where more will be coming from major hardware manufacturers. Now, all of you also know Google Maps, so you know that you can retrieve information that is related to, let's say, the piazza on which you are currently standing, but that is a relatively coarse-grained thing. So if you retrieve Wikipedia articles related to your current GPS location, it will tell you everything about the vicinity. Whereas we are interested in superimposing precisely in time and space computer-generated information on top of the video feed of the real world. So we are really talking about high frame rates. If you have a camera that captures video with 30 frames per second, that's approximately what is going on today on standard devices. Then we would like to overlay content that is accurate in the real world up to 1 centimeter and 1 degree of arc. So this is not like the coarse-grained GPS kind of georeferencing that we're seeing in conventional applications. And on top of that, it should work anywhere. It should work indoors and outdoors. For tourism, obviously primarily outdoors, which makes it relatively harder because you cannot rely on any pre-installed infrastructure. You don't even have a power supply and so on. And it should work with a really easy interface. This is why we're also working with the University of Padua on the human-computer interaction problems. You would like to have something that could be called point and shoot. Yeah? So without any user training, these apps should be understood by pretty much everybody. Augmented reality is not a new idea. It has actually come quite a long way. I've been doing this for almost 20 years now. However, in the past, we didn't have the hardware and the software to make that really working. So I dug in my video archive, and I'll show you a very crappy, low-resolution video from 2004, actually. So we built this first system in 2001, and a couple of years later, things looked like this. So already a head-mounted display, but you have to wear a laptop on your back. This is in Vienna. This is Charles Cathedral in Vienna. And here you see some cultural overlays like we did them back then, so you can get some information on the frescoes in the dome, for example, by just looking at them. But obviously with some very bulky hardware that is not really useful for everyday operation. That was more like, can we do it at all? And then things have moved on to smartphones. So the middle picture shows a relatively new commercial example. And in the future, we may maybe even see wearables like the Microsoft HoloLens in the picture here. What do we do with this type of system? Well, I would argue that there's an emerging new class of browser, the augmented reality browser, which gives you access to information that is situated, that is anchored to some object or concept or place in the real world. So by just looking at an object of interest or pointing with your smartphone, you can retrieve that information. And in that sense, everybody knows how to use a web browser. So what do you do with a web browser? Well, it's a general purpose tool. You give it an internet address and it gives you information from there. Now you point your AR browser at an object and it gives you information related to that object. And that is a very lightweight interaction. If you want to use a web browser, even on a mobile phone, you still have to type in the internet address and you have to stop everything that you're doing. Most people will not be able to keep walking or have a conversation while they're using a web browser. Here it should happen more or less spontaneously as a byproduct of looking or pointing at things. Obviously the information doesn't only have to come from curated sources like cultural heritage databases, but it could also come from social media. It's the same thing as we see with web. Other people could give you information like, look, this place has really good ice cream. This is the kind of information that you could get there. And there's a lot of potential for such augmented reality browsers. I've listed a number of application examples here. Tourist guides come in the first place because they are relevant in the CultAR project, but there are many other things like virtual sticky notes or advertising or repair procedures, training, instruction, fitness instruction, and things that you might not have in mind first. So Italy is the land of the Panini stickers for the soccer championship. So I'm sure my son would love this if you could turn your soccer sticker collectible book into an animated version that shows you all the great players. If you are interested more in a professional kind of application, then for example, if there's construction going on, there's always the danger that some caterpillar driver digs up the ground and breaks the power line that is underneath, and there's actually a law that requires that they have maps of the environment, and this can still go wrong. And with the right kind of tool, the whole issue of street surveying and inspecting underground infrastructure can become a very different kind of thing. So here you see not only the inspection of where is the power line, so I don't disrupt it inadvertently, but you can also do some replanning of the power line. So they're now going to make some basically computer-aided design operations directly in the real world, like where to dig is marked up in green. No spray cans anymore, you do it on the computer. Yes, so this has quite a few technical challenges. One of the biggest is outdoor localization. You need to find out where you are if you use the mobile device, and the way you can do that is you capture the video from the camera of the device and compare it to a big database that contains a 3D model of the city. And if you have a match, then you found the place where you're standing. So what does this 3D model look like? Well, it's also made from lots and lots of images, but then they are converted into a big point cloud. So maybe some of you recognize this location. obviously taken from the CultAR project here. This is the kind of database that we are using to compare the video to. Then if you want to find out where you are, it would give you this kind of impression. This is an example that we've done at my hometown in Graz. Now that would be a terrible example because nobody wants these advertising billboards stuck to the facades like that. But you see that you get very nice, what we call registration. That is the billboards really look as if they are glued to the facades in this place. This comes from this image-based recognition where we build a model of the place up front and then we do this video matching. So with this kind of technology that runs on standard tablets now, you can get the technology going for augmented reality. And now we can move forward to presenting the content. And there another issue pops up. You probably know that from long and complicated web pages, there can be an overflow of information. The same happens if you now anchor information in the real world. So you give some request, but there's too much information and you only end up with a big clutter. You can't make any sense of it. And obviously, by making some more specific selection, you can bring that down to a smaller set of data points, and that is maybe easier to handle. But you still need some kind of clever arrangement of the information because you're trying to look at the video of the real world at the same time. And if you occlude everything from the video, all the pixels of the video with some text or whatever information you have, then you're not going to get the connection going. So the problem is what is called view management, which is basically a layout problem. And here you see on the left-hand side what happens even if you have an algorithm that already avoids the object, in this case the head model. So that's not outdoors, that's obviously an indoors scenario, an anatomical example. Even if the labels avoid the head, it's still not working if the user is moving. And on the right-hand side, you see how we have developed a technique that is basically doing that in a more clever way, that is not only avoiding the objects that you do not want occluded, but also doing it consistently in 3D. So you get some impression as if somebody had put some, well, flags or poles into the head. And that makes a much nicer impression if the person is actually moving around. And we're also trying to use that outdoors, although outdoors you have much less control over the situation and that it's relatively challenging. So these are some of the main things that we have done for the CultAR project. I don't want to take too much of your time, but I thought I'd talk maybe about one or two additional examples. So let's start with some obvious thing, namely the social sharing of annotations. This is something that we've already started in CultAR, but bringing it to a level where it can really be deployed on a, a professional scale is much more work and also requires more resources and infrastructure. But in principle, it's relatively easy. If you have this system that can deliver geolocated, geo-registered content via augmented reality, then you can also let people input that information. So in this example here, a guy called Peter is creating some new annotation, like I like this ice cream shop. And then you store it on a server, and then his girlfriend Mary can download that when she comes to the same location and experience this information. And here's a little video clip that shows how this is going on. So here's an augmented reality browser, very simple one. And now the user is clicking a button and is adding an additional annotation, in this case the name of the building. This is then registered in the database alongside with the 3D model that we have of that building, and therefore other people can retrieve it at a later point in time. I think this will become important as a new kind of social media. If the same people who are using Facebook to document everything that they're doing and already cross-referencing it with Google Maps or some GPS location will be interested in that kind of thing. And another aspect of social media is situated video. So there's a lot of selfie videos going on now, and also people who do sports or who do all kinds of things document what they're doing on video and then are sharing those videos. And you can now register videos to the location as a new type of medium. So not only can you input some text that is a textual description of an environment, but you can also show what the person is doing there. For example, a skateboarder has been pre-recorded here and is now registered again to the environment. So for example, people could compare how good their skateboarding in a particular location is. And you can walk around and look at that from all angles. In this case, the mobile phone was set up on a tripod, but in principle, you can do lots of these effects that you may know from sports channels now in the real world. And we think that will be an exciting application that can also relate to a place. Yes, and if you want to go even deeper into what people are doing, then you can even go to physical instructions, and that has also some nice applications. So some applications might be, more professional, like teaching somebody how to solder, and we can extract that kind of motion directly from video and teach a person how to do it, or I don't know, to learn how to do your makeup in this case. But if you try to get involved in some more cultural activities like cooking, for example, then there may be more complex motions involved. Or here's instructions how to not cut up your fingers along with the cucumber. But I'm actually waiting for this final example in this video clip. Everybody knows that if you go to a foreign place, there will often be these entertainment nights where you learn how to dance. In this case, for example, German folk dancing. That can be relatively challenging. Ah, that was short. Let's see if I have some more. You can learn the motions that are extracted from some video and that allow you to deal with these physical skills that you need to acquire there. And we've actually tested that, and it seems to be fairly effective, presenting motions from a first-person perspective, in particular with a head-worn display on. All right. Yes. So let me wrap it up. I think AR will become an important new medium. Tourism is an important field of application, and we've made some really big steps forward in the CultAR project in bringing that into the real world. But obviously, tourism is only one form of activity, and augmented reality could also be used for many, many more activities. An interesting aspect, I think, is that if more people have this technology available and have access to the devices, then augmented reality can become also a social medium. And then this whole process of being outdoors, being a tourist, and social sharing with your friends that are or are not in the same place will become much, much more richer through this new technology. That brings me to the end, and I'm happy to take your questions.